And now next session we have here is making steel for public infrastructure for mass transits, airport, railway stations, bus stands, inland waterways and high-speed motors. And the speakers for the session. So let's welcome our moderator, Mr. Vijay Sharma, Director, Jindal Stainless. Can we have a round of applause for him? Mr. Ravi Kiran Mandumula, Regional Sales Manager West, Tubes Division, Tata Steel.
I am about to reach the midway of my curiousness. Another trend which is becoming very apparent is the speed to the mass transit. I think Tata is heavily involved in the bullet train, the role model. We would like to have your experiences from a supplier perspective, how you are facing it, how you are doing it. Mr. Ravi Kiran, he is from Tata Steel and in bullet train, very deeply involved. He will share his experiences.
Good afternoon, everyone. So it's my privilege to be here today to not just share the Tata Steel's journey, but it is also to show a glimpse of the future of the Indian steel industry as we contribute to one of the India's ambitious infrastructure project, the Mumbai-Ahmedabad high-speed rail project, which is also famously called as Bullet Train project. This 508-kilometer corridor will be the first highest high-speed rail project in the India using advanced Japanese Shinkansen technology designed for speeds as maximum as 320 kilometers per hour. Among many engineering challenges, one of the requirements which stood out is the requirement of the 20,000 traction masts that need to take the loads, varying loads at the higher speeds, but also meeting the stringent Japanese industrial standards. Simultaneously, we aim to support the Make in India initiative by emphasizing localization and import substitution. It was indeed an uncharted territory for the Indian steel industry, but however, that is where Tata Steel took the lead. Now, when the contract for the electrification mast was awarded to L&T, so they encountered a lot of challenges with respect to the sourcing of steel tubes. There was rising pressure for getting the steel tubes imported from Japan, citing the quality concerns. So the Japanese consultants were very skeptical with respect to the whether Indian manufacturing has the capability to meet the very finer chemistry, mechanical and dimensional tolerances. So to elaborate on these parameters, traction masts are subjected to dynamic loading at various speeds, meeting the standards. So it needed very adequate strength, ductility and toughness. Corrosion resistance properties are also required for this material as the bullet train passes through the coastal areas or the polluted zones. Traction masts would be inserted into very predefined slots on the decks across the bridges, and hence tight dimensional tolerance were also required for the best fitment and have good structural integrity. Last and foremost, these full-scale prototype testing at complete payloads was also a mandatory requirement to give any clearance for these pipes. So these were the technical challenges which L&T was facing. On the other side, if we see, import dependency would increasingly be increasingly expensive, considering 2-3 parameters. Advanced planning required for the long lead time for these many tubes to meet the commissioning deadlines, because you do not know how fast sometimes they are pushed. There are governmental pressures also to meet the deadlines. Inventory risk, considering for the planning to be done for the 20,000 pipes for the length. Dealing with the high import cost, considering the volatile global supply chains which we have been seeing for quite some years now. For the India's first bullet train, L&T had to choose from the two choices: remain dependent on the imports or take a leap and partner with a local competent local provider. Fortunately, L&T posed this challenge with Tata Steel, and that's where we recognize that it is not an obstacle for us, but it is a remarkable opportunity for us to localize a globally benchmark solution at a very low cost. So at Tata Steel, we viewed this as more than a supply contract. It was an opportunity to demonstrate the Indian engineering proficiency and cement our position as a partner in a nation building. So through early technical engagements with all stakeholders, right from the project consultants, project owners, contractors and subcontractors, we try to decode the requirements of these tight, stringent Japanese standards. And we did this through 3-stage framework, which is we engineered the material chemistry, which is developing low carbon steel, microalloyed steel grades, which are equivalent to the Japanese STK 540, STK 500 grades, to achieve the high strength and high ductility, as well as achieving the zinc addition, which is required for the corrosion resistance, which was I mentioned earlier. So we also introduced process modifications in terms of the thermomechanical rolling parameters to achieve the ductility and toughness of the material. Last and most important part, I think we devised robust quality assurance processes which were required to pass on the factory acceptance test and many tests which the consultants initially did. So over a period of 12 months, through joint inspections, we achieved the first ever approvals for manufacturing high-strength steel tubes locally. So this is transitioning from pilot trials to the commercial supplies. So with the impressive results and boosting confidence, this is a journey we traversed from skepticism which was surrounding our capabilities to the endorsements. As you can see, I'm just sharing the very proud moments when our railway minister showcased these erections as part of the project which is there recently and endorsing our value. So for Tata Steel, the initiative we are not merely seeing this as any supplying of steel tubes, that any regular order which we had. It was about proving that innovation, Indian innovation, can meet the global standards that was being looked for. So it's also about empowering our contractors to have localized solutions, empowering our contractors that they can eliminate completely the import dependence, which was the key area, reduce project costs, and also ensuring uninterrupted supply chain to meet the deadlines. So all these, I think, paved the way on what all of us were talking about is towards making self-reliant India. Looking forward, so with these kind of advancements, with this innovation and success, I feel that Indian steel industry is poised to be a strategic partner for the future high-speed rail corridors and has built a robust foundation with respect to many innovations that can be done around the rail infrastructure and exports markets. The Mumbai-Ahmedabad project, I think it has pushed us, indeed tested our limits of speed, strength and agility. As you can see, I mean, there is 0.5 million tons of opportunity we are seeing for this kind of steel traction marts in near future. I would like to just draw your attention to this picture which I am showing. Whenever the Mumbai-Ahmedabad bullet train starts, whenever one of us, when we sit into the train and conduct this journey, probably it will be a proud moment for all of us to see the strength of the Indian structure in the form of the traction mast. Probably this is the only structure of the bullet train which you will sit in the train and you can see across the length of the 508 kilometers. So that is what the proud moment we feel it is. In conclusion, I am proud to say that this is Make in India and in action. Thank you.
Thank you, Mr. Ravi Kiran.
Just to add,
We
sir,
were
just to add, as I mentioned that in the ropeways about 70% of the material is made of steel. So I would like as he rightly mentioned that there are technical challenges. There are various codes which these countries follow, and based on that they approve the design. So there is one more opportunity of developing ropeway systems with components and materials which can be made in India based on their codes and certified as per your experience in the railway project. So that will again boost the efficiency of Indian steel industry and also bring down the cost which we right now have to get it from the European manufacturers, because ropeway is a very in India it is as of now at a very nascent stage. So that's another opportunity for the steel industry to come in and develop these components of ropeway.
Thank-
Just one thing. Actually, what you wanted to say is in the ropeway industry, whatever manufacturing is being done, that is being done in steel, and one should try to reduce the cost of this construction by doing some innovation or by doing some collaboration with the steel industry. That is your point.
Yeah, it's more of a collaboration,
yeah,
sir,
yeah.
because as he also mentioned that the
Exactly.
high masts
Exactly.
were to be imported,
What I
but
wanted
they
to say on
manufactured in
this
India.
is, what I wanted to say on this, you can do that provided you create the volume.
Yeah, I agree.
And volume can come when you do the standardization of your processes. Your designs, if they can be standardized, modularized, and then they can do the rolling of the steel products accordingly. Am I right, sir? So that will help. But problem is ki right now, I don't think in ropeway we have got that kind of a volume that you can actually do the manufacturing suiting to their requirements.
Yes,
So there is a scope to interact and then decide how to do standardization, how to create the volume so that it is beneficial to all.
Sir, I would like to thanks for your suggestions first and foremost to both of you. In this industry, how we view things is that this is not a given industry. It is in this tubular structural section, it is that we need to collaborate with all agencies, the industries, and see that how we can add value to their operations.
Exactly.
So it is daily, so we never see of course, the scalability, all those aspects we definitely look into. Like even for bullet train, this is a journey of 3 years for us. In business, if you, today you invest and tomorrow you need the results. Okay, but this specific structurals or hollow section tubes, which I was mentioning, sir, it's just that, all these suggestions will help us. It's not that, even our idea, when I mentioned my concept of bullet train, what we did, it was not, I was not mentioning only for the bullet train. It is about the mindset of how we should engage with the industries and see how we can add value.
to add make in India.
I think Mr. Ravi Kiran, learning for me is bullet train was not the hero of the story. Hero of the story was resilience, processes, systems, and dedication. Because the challenge of the MOQs, it is a very normal and natural challenge whenever new thing comes. It is always there. That struggle will always be there. But you demonstrated well how we are not less than anybody, and perhaps we have crossed this also. Thank you for this. 15 seconds to you, rejoinder, and 15 seconds to you. She's steering me
So
very
I
hard.
just wanted to substantiate one point what we were discussing with Prashant sir and Ravindra sir. So to understand the role of the hollow section, sir, and what we do in our segment, let me take you back 20-30 years to our airports. If you visualize, these were the simple boxes built of the TMT were with very closed spans. Okay, but with the usage of the hollow sections and our lattice truss systems usage, we have been able to build in very beautiful and aesthetically looking airports, now railway stations and metros. Just I wanted to mention this point to give a better perspective. If 20-30 years back, if we were thinking that okay, there is no market or demand and we can scale, we never thought that 100 airports Udan scheme will come. Okay, even the smallest airport now have the larger spans which is being built. So that is the role of hollow section which we passionately get into, because this is a subject which we see with very passion because you have stoked our passion. So I wanted to come in. And lastly, sir, thank you so much for passionately giving me this opportunity and taking time from
I
Monica.
appreciate your passion. You will get good business.
Last but not the least, Mr. Ravi Kiran Mandumula, Regional Sales Manager, Tubes Division, Tata Steel. Now I request our moderator and all the speakers for a group photograph.